Running an engine on diesel fuel is efficient, but it emits smelly black exhaust, soot, leftover carbon that didn't burn off in the combustion process. To prevent exhaust emissions from polluting the air, diesel engines and diesel power generators need powerful filters. This self-cleaning diesel filter traps engine exhaust soot and burns it off by heating the filter elements. This effectively completes the combustion process. At the core of those filter elements are heating strips made of steel fiber, which is like dense steel wool. But the steel is a special mix of alloys resistant to high temperatures and corrosion. Each heating strip goes into a machine which repeatedly folds it up, then down, pleating it like an accordion. The thick steel fibers are what trap the soot particles as the engine exhaust flows through. An electrical current heats these conductive fibers, burning off the soot regardless of engine exhaust temperatures. Using nickel crimps, workers connect, depending on the filter size, up to 7 pleated strips per filter element. They press the crimps securely into the steel fiber with a press. They attach a different type of crimp at the far ends. This type has a tab with 3 holes for the electrical connections. Next, they bend the assembled strips into a circle and place them inside a perforated steel housing. A temporary cardboard spacer creates a gap between strips and housing to insulate against short circuits. The electrical connection tabs on the ends fit through slots at the front. An insulating block made of mica, a non-conductive mineral, goes behind the tabs, followed by steel fiber spacers. All this sets up a clear and strong conductive path from the power source to the strips. They fasten the insulating block to the housing. Then, using tweezers, they place a mica spacer in between each pleat. This prevents the pleats from touching each other and causing a short circuit as the electrical current passes through the strips. They place a spacing stick inside each pleat. This is just temporary to size the pleat's width uniformly until they're cemented permanently in position. To do that, workers pour ceramic cement into a circular bottom plate made of perforated steel. The perforations ensure better bonding. They spread the cement evenly across the plate. Then, position a stainless steel tube in the center to connect this plate to an identical plate on top. They carefully place the strips into the cement and position the top plate. Then add a weight to hold it down while it goes into an oven at 85 degrees to cure the cement. "45 minutes later, they take it out of the oven and remove the top plate. They also remove the spacing sticks and cardboard spacer, which are no longer required because the spacing is now permanently set in cement. They repeat the cementing process with the top plate. After a final 4 hours in the curing oven, the electrically heated filter element, this diesel filter's key component, is completed, and the main assembly can begin. The larger the filter, the more filter elements it contains in its stainless steel housing. For this mid-size model, technicians stack 4 sets of 6 elements, then connect electrical cables to the tab holes of each one. Next, technicians install a flow control valve for each stack. When activated, the valve reduces exhaust flow to that stack, enabling the system to automatically clean elements by electrically heating the strip. An internal computer manages the cleaning cycles. It uses sensors that detect soot accumulation in the elements, isolating and cleaning one or multiple elements at a time. On the front, techs mount the inlet flange, through which the dirty diesel exhaust enters the filter. On top, the outlet flange, through which that exhaust exits soot-free.